Okay, so now we'll be talking about the golden ratio. So to use the golden ratio, we are going to use our Fibonacci numbers. So let's start with 1, 1, 2, 3, 5, 8, 13, 21, 34, and 55. So this is a set of Fibonacci numbers. Again, how do we get our succeeding elements of a Fibonacci number? We can find out our next elements of a Fibonacci number by simply adding the last two elements. So for example here, we have 2, this is the third element. We need to add the first element and the second element. Then how did we get 3? We need to add our second element and the third element. At the same time, that applies to all. Now, we are going to manifest here, how is this golden ratio? Take note that our golden ratio is approximately equal to, this is the value of our golden ratio. It is pi 1.618. This is the approximate value of our golden ratio. Now, let us try to find out the ratio among the different elements here. So let's start with the second element by the first element. So we have 1 over 1. Then we have the third element over the second element. Then we have the fourth element by the third element. And we have the fifth element by the fourth element. Then we also have here 8 over 5. Then we have 13 over 8. We have 21 all over 13. Then we have 34 all over 21. And we have 55 all over 34. So now we are going to find out now the result, or simply getting the ratio of the following. So here we have 1 divided by 1, this is equal to 1. Then 2 divided by 1 is equal to 2. 3 divided by 2 is equal to 1.5. Then 5 divided by 3, this is approximately equal to 1.666. Then 8 divided by 5 is approximately equal to 1.6. Then we have 13 divided by 8, this is approximately 1.625. Then we have 21 divided by 13, this is equal to 1.615. Then 34 divided by 21, this is approximately equal to 1.619. Then we have 55 divided by 34, this would be equal to 1.617. Now, the values of the ratios of the different elements, the last two elements of a given Fibonacci numbers, as we get the ratio of the greater pair of numbers, then we would be going nearer to the value of our pi, which is equal to 1.618. Now, let us try to represent this value by showing a line segment. For example, we have this. We have this particular segment. Now, let's say this is our shorter line segment denoted by S, and our longer line segment, so it will be denoted by L. So from this, by using our golden ratio, this means to say that the ratio of the longer side and the shorter side, which is denoted by S, is equal to the ratio of the sum of the shorter side and the longer segment over the length of the longer segment. So I will repeat. This means to say that the shorter segment would be the sum of the shorter segment and the longer segment over the longer segment would be equal to the ratio of the longer segment and the shorter segment. Okay, so let us try to assume that the value of our shorter side is equal to 1. So now we are going to replace our shorter side or shorter segment by 1. So we have here L over 1 is equal to, we have 1 plus L all over L. Then now we are going to cross multiply. So cross multiplying this, we have now L squared is equal to L plus 1. Now, as you can see, we got now a quadratic equation. So we have here L squared minus L minus 1 is equal to 0. This is now the standard equation of a quadratic equation. Now, the value of our A is equal to 1. The value of our B is equal to negative 1. The value of our C is equal to negative 1. To find out the value of L in our problem, we are just going to use our quadratic formula. Our quadratic formula would be equal to, we have L is equal to negative B plus or minus the square root of B squared minus 4AC all over 2A. By replacing the values of A, B, and C that we got from this quadratic equation, we are just going to substitute your small a, small b, and small c in our quadratic formula. So we have negative times negative 1 plus or minus, we have the square of b, we have negative 1 squared minus 4 times our a is 1, then our c is equal to negative 1 all over, we have 2 times our a is 1. So simplifying this, we will be getting now the value of L, which will be equal to negative 1 times negative. This would be equal to 1. Plus or minus, we have the square of 1, that is equal to 1. Then minus negative 4. So 1 plus 4, that would be equal to 1 plus or minus the square root of 5 all over 2. So if we are going to get the approximate value of this, 1 plus or minus the square root of 5 all over 2, this is approximately equal to 1.618 approximately. Since this is a quadratic value, this is one of the roots of the quadratic equation, we are going to remove our negative sign. We are just going to get the principal root, which is the plus sign. Now, if we are going to use now the relationship from the stated above, we have here your L over S, wherein L over your shorter segment, your longer segment is equal to 1.618 all over the value of S is equal to 1, and this is equal to 1.618. Now, if we are going to find out the value of S plus the longer segment all over the longer segment, this would be equal to, we have S is 1 plus 1.618 all over L, which is your longer segment. This is also 1.618. Now, if we are going to simplify 1 plus 1.618, this would be equal to 2.618 all over 1.618. Now, if we will be dividing this, the result would be approximately equal to 1.618. So, this is the meaning of golden ratio. By simply getting the ratio between the longer or the bigger value to the smaller value of any Fibonacci numbers, that would be resulting to this value of pi, which is equal to 1.68. The value of pi would be resolved as we move further in computing the values of the pairs of Fibonacci numbers. That's it. Thank you.